So hi all, welcome back, and in this video we'll be talking about design principles. So what are design principles? Design principles are fundamental guidelines and best practices that help developers write clean, maintainable and scalable code. So it helps us as a developer to follow these best practices so that we can write clean, maintainable and scalable code. So you can think of them as a rules of thumb or philosophies that guide how you should write and structure your code, right? So think of design principles like, for example, traffic rules, right? So these are set of guidelines, right? These are set of rules that keep everyone safe and organized, right? So similarly, you have set of rules or best practices that you can follow in software design so that your code at the end of a day looks maintainable and scalable, right? So let's understand what are design principles. So design principles, as I said, they provide guidelines for writing better code, right? They are not strict rules, but but rather philosophies that help you make better decisions, right? So these are kind of, they are not strict rules that you have to follow, but if you follow them and if it makes sense to follow them, then you'll have a clean code. So if you see in this visual, so whenever we write code, if you follow these design principles guidelines, you'll have some clean and maintainable code, right? So before we further proceed into this article, let's see these design principles first, and then come back to what happens if you don't use those design principles, right? So now let's talk about dry principle. So dry principle means don't repeat yourself, right? So if you ever find yourself in a situation where you are duplicating the code or logic that you wrote earlier, so that means you are violating this principle, right? So let's understand it better, right? So the dry principle is one of the most fundamental principles in a software development, right? So the dry principle states that every piece of knowledge must have a single representation within a system, right? So every logic should have a single representation. If you are duplicating the same logic multiple times across your code base, what happens if you want to do some single change, right? If you want to modify the logic, then you essentially have to modify the logic in several places, right? Because you unnecessarily duplicated the same logic multiple times across your code base. If you want to modify it or tweak it, you have to, refactor all these changes, right? So you have to refactor all the files wherever you have this duplicate code, right? So simple analogy is, you can think it is of a recipe book, right? So if you write the same recipe in multiple places, you have to update it everywhere whenever you change it, right? So if you write it once and reference it, you can only update in one place. So this is much easier to maintain, right? So this is the main, this is a very simple analogy to understand dry principle. So what does dry principle gives you? The first thing is you can reduce the duplication. So you write code once and use it everywhere. Easier maintenance, right? Change code in one place. We saw this. If you repeat yourself across multiple files in a code base, if you want to, tweak the logic in one place, you have to go through your code base and refactor in all the places wherever you have duplicated this code. Consistency, right? So same logic behaves the same everywhere, and then you have less bugs, right? So if you fix in one place, that means you are sure that this will not happen again. Better readability, right? Less code to read and understand. So if your logic is spread across the code base and it is same, if you are duplicating it, it is tough. The readability part becomes tough, but you have it in one place, the readability part will also be improved. So this is a simple, visual, like you without dry, you have function one validation logic, you have function two, and here also you are doing the same validation logic, and function three, here also you are doing the same validation logic. But with dry, what you get, so you have a single function and a validation logic defined in one place, and all this further whatever functions you write, and if you want to use this validation logic, you'll reuse again, right? So you don't need to, sort of duplicate it again and again in different files. So you have your single source, and all these individual functions use the validation logic from there, right? Now what happens if you don't follow dry? as we saw earlier, duplicate code. So same logic is repeated in multiple places. Inconsistent behavior, maintenance becomes tough because you essentially have to update code in multiple places, more bugs and harder to test, right? So see this example, user validation example. So you have register user, you have a function called as a register user. This takes email and password, and then it has some validation logic here, right? And then the actual registration logic is there. And then similarly you have a login user function. It also has this validation logic and then the actual login logic. And similarly you have a function called as the reset password. You have the same validation logic here and then the actual reset logic, right? So what is happening here? So you're essentially duplicating, like, so every time whenever your function calls register user or login user or reset password, right? So this validation logic that you see across all these three functions is essentially duplicated, right? So you are just violating this drive principle. So what happens, let's say if tomorrow you want to add another piece of validation here, then you have to modify in the register user, then you have to modify in the login user, then you also have to modify in the reset password, right? Apart from this, your testing side also becomes tough because now you have to essentially modify the testing functions which test all these three functions, right? So whatever the test cases that you write to test these three functions, you have to modify there too because you have modified the logic in all these three places. So let's see what happens when you apply this drive principle, right? So see this example. You have created a new class called as class validator, right? And then you have two static methods. The first one is the validate email and second one is the validate password. And here is the validation logic, right? So here is the validate email logic, here is the validate password. Now in all these three functions like register user, login user or reset password, you can directly make use of the class that we defined above. So you can say validator dot validate email and then you'll pass the email. Similarly, you can use validator dot validate password and pass the password, right? So same thing across all these three functions, right? So let's say if you tomorrow you want to add another validation method, you can simply add it to this class, right? And similarly the testing of this class also becomes easy, right? So you don't need to modify several places in whatever the test function is testing this class validator, you have to change it in one place. So what are the benefits you are getting? Validation logic is in one place, right? Change validation rules once and these affect all the use cases, consistent behavior and easier to test, right? And then maintainability part is also easy, right? Readability is also easy. Like anyone can see this validator class and then they can see all the validation methods listed in one place, right? So this is what happens if you use a drive principle. Let's see another example, right? Database connection. Let's see how this works. So you have a class called as user service, and then you have two methods, obviously. So to get user and then create user. So to get user, you first have to create a connection with the database, right? So you are doing that in line number 6, and then you are querying, and then finally, once you get the user, you are closing the connection. Same thing here. So you are in create user. Obviously, for you to create user, you first have to connect to the database. You will be having the insert logic here. And then once you are done with creating a user, you are closing it, right? So let's refactor this. You saw this, right? We are duplicating this, logic of creating connection multiple times across multiple functions. So let's see how we can have a single source, right? So you define a class called as database manager, and then you have one static method saying execute query, right? So what does it take? It takes a query and all the parameters, right? So what happens is you are essentially handling this connection logic here. So whatever the connection logic that you are duplicating earlier in individual methods, here you'll have one single source of database connection, right? So whatever query. Let's say in this case you want to get a user, or in this case you want to create a user, right? So that query you can pass it as a method parameter, and then once connection is established, right? So if we can see, you are creating a connection, and then you are executing this query along with the params that you are sending, right? So that means you're having one single source of all the database operations, right? So let's say if you want to add some log, right? So you can add this log in one place, and then for all subsequent database query operations, you can see how does your application query. So you have a user service, and then in the get user, you are calling this database manager, right? So this is the class database manager, and then you are doing something called as execute query, right? Same thing that we saw here, execute query, and then what are you passing? The first parameter is the query, right? And the second parameter is the actual parameters for this query. So you are just reusing the database manager. So there is no concept of duplication. Same thing for create user, right? So you are also making use of the existing database manager. You are not kind of duplicating it. So when to apply dry? So whenever, if you see that there is some logic that is appearing multiple times across, and then you have to, then you have to extract into a function or a class. If your business rules are getting repeated, you have to centralize. Similarly, if there is some configuration values that you are duplicating, then you have to use constants. Similar code patterns, you have to create reusable abstractions, right? So we saw this briefly in earlier videos, but yeah, when you have to, usually when you'll be applying dry, so whenever you think that you are repeating the logic yourself multiple times, you have to make use of dry principle. So now let's see when not to apply this dry principle, right? So whenever code is similar but different, right? So you don't need to force the abstraction and premature abstraction. So wait until you see an actual duplication, right? So in your previous examples, we actually saw that I know there is some code duplication happening. So the thing is, you don't need to start with implementing dry principle. So whenever you are writing code, you think that you are duplicating the logic same, then you have to refactor into making use of dry principle, right? From the day one, you should not think like, okay, in future this logic might be deduplicated, so I have to apply dry principle. So that's not the use case, right? So obviously for things like database, right, this is a classic thing where you will be reusing. So you can, from day one, you can make sure that you are abstracting in a single class. But for other scenarios, you don't need to think it from day one. So once you actually see that there is some code duplication happening, only then you apply the dry principle, right? So you have to find the right balance. So dry is about eliminating real duplication but not forcing everything into abstraction, right? So we should not think that this in future might be duplicated, so you have to abstract it from day one, right? So sometimes a little duplication is better than over engineering from day one. So that's all for dry principle. Okay, so time to talk about this YAGNI principle. So all these principles are quite easy. Like, I mean, from this first line itself, you can understand, right? So dry principle says don't repeat yourself, right? So D corresponds to don't, R corresponds to repeat, and Y corresponds to yourself. Similarly, this Yagni principle says you are gonna need it, right? So let's understand it, right? So the Yagni principle is a core principle of extreme programming that states don't add functionality until it's actually needed, right? So this is something that is very important, right? So whenever you are trying to build an application, right? So from the day one, don't think that okay, in future I might want to have this authentication. Let's say you are building a simple React app, and then you are thinking about authentication, right? So don't think from a day one that okay, from I have to, in future I'll be supporting Google Auth, Facebook, multiple social authentication methods, and have the logic for all these methods defined, right? So from the day one, you don't need to think about that, right? So this is a simple example. We'll understand more, right? So in simple analogy, like think that you are building a house, right? So you might think I'll be building a swimming pool, gym, and then home theater, right? But you actually need only bedroom, bathroom, and kitchen right now, right? So building extra rooms you don't use waste time and money, right? You can always add them later when you actually need them. So this is a very simple analogy. So Agni says build only what you need when you need it, right? So let's say if you go back to the previous example that we said, let's say you are in MVP version, right? You are building a product from scratch. So in your MVP version, you can scope the authentication to, let's say, username and password, right? So in for that MVP, you only need user to authenticate via username and password, right? So that is fine. So your code base should have only logic till that state, but you should not think that okay, in future I'll be supporting numerous ways of authentication and start writing logic for all these authentication methods from day one, right? So that's what it says, build only what you need and then when you need it. Let's say in from MVP you are going to V1 phase, right? So if in V1 phase you are planning to support more authentication methods, then it's fine, you can start building at that phase, but from the day one you don't need it, right? So what does this says? Avoid over engineering, right? So don't build features you don't need. Save time. So what, instead of building the features that you don't want from the day one, save time and focus on actually what's needed, right? For let's say you are building a React app. So you can save time there and then let's say invest that time in making your app performant, right? So you can add something like a CDN and all these stuffs, right? So you can work on the performance aspect of your site so that whenever one user comes to your application, the load time should be instantaneous, right? So you can save time here and instead invest the time on somewhere else. So reduce complexity, right? So if you have less code, that means you have less code to maintain. Faster delivery, right? So if you keep on working on the authentication layer itself, so your delivery times might be more, right? So if you don't do that, then you'll have faster delivery times, right? And then flexibility. So add features when requirements are clear, right? So if the requirement, let's say if V1 requirement of your product says that you want other authentication methods, only then start building those authentication mechanisms. So the simple visual without any needed features and then unnecessary features, just in case you'll have both of them in your code base. Whereas once you apply Agni, so you'll have only what you need right now, and then rest you'll develop it later, right? So let's take a simple example like user management system. So what does it say? You have a class user, right? And then you have a constructor in it, so you'll have self dot name and email, and then see the same example that I told you earlier, right? So for future, so you are saying that okay, I might have to store social links, might have to store preferences, subscription tier, notification settings, analytics data, right? So do you need all these things from day one? No, right? There's no need for us to write logic for all these things from today, right? So this is one example of over engineering, right? So if you don't need all these things, you don't need to have these hundreds of methods that that do various things which you don't need for the current version, right? So if you refactor using Agni, this is very simple. So if you need only name and email authentication as of today, so you only have class user with name and email, right? So something like that. So build whatever you want today. Don't think very much ahead and see that okay, I want all these authentication methods, notification settings, analytics, and all these things, and then create such unnecessary complexity. So let's see another example. This time backend, right? So here is a class user API, and then you have get user, create user. You need this, and then there are several methods like update user preferences, get user analytics. You don't need export user data, right? So all these things you don't need now. So when to apply Agni? So whenever you are building a new feature, only build what is needed now, designing abstraction. So it says don't abstract until you see a duplication. Adding nice to have features, that is not that you have to do. Skip, unless you actually need those nice to have features. And then premature optimization, so don't optimize until you have performance issues, right? So build your app the usual way that you do, and once you observe any performance issues, like if you see that the home page is loading low in Lighthouse, etc., then you might have to optimize it, right? So that's all on YAGNI. This is very simple principle. You can directly understand it from the definition itself. You aren't gonna need it, right? So build only what you need and then when you need it, right? So from the day one, you don't need to over engineer and think of all the ways that you have to serve your users and start writing logic for all those use cases, right? So this is all about YAGNI. Okay, so now let's talk about this KISS principle, right? So it says keep it simple, stupid, right? So simplicity is the ultimate sophistication, right? So this is very easy to understand, right? So you have to keep things simple. So what does it say? So this principle states that simplicity should be a key goal in design and unnecessary complexity should be avoided, right? So whenever you are building an application, you have to keep things simple. You have to keep your logic simple, right? So that should be your key goal in your design, and then you have to see if there is any unnecessary complexity. So if it is there, then you have to avoid it. So what does KISS principle gives you? You have logic that is easier to understand, easier to maintain, faster development, right? So better performance and easier to debug. So because your logic is simple, so you essentially getting all these advantages, right? Your code is easier to read. You'll have less complexity, means you'll have fewer bugs. Simple solutions are faster to build. Simple code often performs better, right? So you'll have all these advantages. So one thing that you need to understand is when not to use this principle. That is also very important, right? So we'll see those scenarios with an example. So let's take a simple example, right? So finding the maximum number. So let's go to the code, right? So you have find max, and then you have this numbers list that you are passing. So you are doing some validation check here, and then you are kind of sorting all the numbers, right? So see this, right? So step one, you are sorting the numbers list. Step two, you are reversing. Step three, you are getting the first number, and then step four, and then you are validating, right? So to find maximum number, this is such a complex approach, right? So in code, see, you are sorting the numbers. You are again doing some kind of validation to check if it is, what type is this number, and then you are adding some logging mechanism. So all these things, this is over complicating, right? So you don't need this much complexity if you want to find a max number, right? So this is just a simple example, right? So for everyone to understand what this principle says. So here in this refactored version, so how are you finding the max numbers? So you'll have first number as a max number initially, and then you iterate over all the numbers, and if there is some number which is greater than the already max value, you'll return that number, right? Or even simpler version is you can just use the built-in max and then you can pass the numbers. So same thing in you can see the same thing in Java too, right? So what are the benefits? Easier to understand, simple and clear. This is fast instead of the earlier logic, and no unnecessary complexity, right? So these are all the benefits you are getting in this refactored version, right? Let's see another example, user authentication. So you have a class called as this complex auth, and then in this authentication you have username hash, password hash, session token, encrypted session, and all these things. So after refactoring, you might have something that looks like this. So important thing is, whenever this principle says that you have to keep things simple, that doesn't mean that you have to strip out all the security and validation logic, right? So it's not, the idea of principle is not saying that you have to strip out the security and validation logic. It says that if there is any unnecessary complexity that you're having in your code base, that you have to avoid it, but not to remove the mandatory security checks or session checks, right? So these things are mandatory. This is just a simple example, right? So if you see when not to apply this principle, so it says security is critical, right? So some complexity is necessary for security, right? So for sometimes automation adds complexity, right? So some complex requirements need complex solutions, right? Obviously, if your business requirements has some complex requirements, then obviously you'll need complex solution, right? So this doesn't mean, as I was saying earlier, this doesn't mean that you have to strip out, security, uh, logic, and all these things, right? Essentially, you have to find the perfect balance, right? So managing your requirements and then not over engineering, right? So this is also simple principle. You can just go over this article. So that's all for this principle. So now that we have understood all these three principles, let's go back to our original article and what happens. Let's see what happens if you don't use these design principles, right? So you start coding without principles, and then once you see that you have a code duplication, that means you're violating dry, and then you have to refactor your code base to follow this principle. And then any over engineering, you are violating this principle. If you are having some unnecessary complexity, that means you are violating this principle, right? So all these things happen. Let's see this code duplication example, right? So without dry, we saw this, you have this validation logic multiple times, but with dry you are having this in one place, right? So over engineering, so that means you are building features that you don't need, like in this example, preferences, social links. So all these things you don't need from day one, right? And then unnecessary complexity. So KISS says avoid unnecessary complexity. So we saw this too. So that's all for the principles that we talked till now, like try, YAGNI, and KISS principle. So in the next video, we'll understand what are the solid principles, and then we'll come back to the section where we can understand what happens if we violate solid principles, right? So just to summarize everything, so try principle says don't repeat yourself. So if you are repeating the same logic multiple times, abstract it, refactor it, and then place it in one place. And then YAGNI principle says you aren't gonna need it, right? So don't build for all the features from day one. Scope your requirements and then build only for whatever you want as of today, right? And then for KISS principle, it says you have to keep things simple and avoid over engineering or unnecessary complexity, right? And one thing to is notice by this, it doesn't mean that you have to strip out any useful logic like security, validation, all these things, right? So you have to find a perfect balance, right? You have to meet your requirements at the same time, right? Like for example, security and all this stuff. And on the other hand, you also have to make sure that you are not over engineering that logic that you wrote, right? You are not complicating that security logic that you wrote in the first step. So in the next video, we'll be talking about solid principles.